Sam, thank you for joining me today. This
No
is a bit of an impromptu session. So we're doing it live. We didn't announce anything. We did the same kind of prep, but we're doing it more in the spirit of Twitch streaming rather than the traditional YouTube video. So today with me, Sam Williams, we did an episode that really captured the essence of doing like an architecture kata. On Sam's channel, we did a clone of Calendly together, and I did it in a more traditional microservices cloud space, and he did it into the pure serverless way. Sam, welcome.
Thank you very much for having me. And yeah, that call we did last week was really useful, and I think there's going to be a lot of interesting things we can chat about today about the differences between our approaches, and yeah, a lot of very different experiences I think we've had.
I monitored your conversation on one of the LinkedIn posts you posted yesterday, I think. And you asked, if you're starting, it was something it had to do with the topic of startups being recommended, to either do X or Y. Now with the Heroku shutting down, I saw a lot of comments which were pretty much all over the place. What's your opinion on that topic before I go deeper?
Yeah, so originally that was because I saw a post on LinkedIn that said new tech startups should avoid AWS. When I saw this, I was really surprised because AWS has, especially for me, the serverless offering. I think if you can get your head wrapped around how serverless can work, it can allow startups to accelerate incredibly fast and reduce the management and operations. The original poster, the reason they'd posted it was, I think they'd spun up an EC2. And in that process, they'd had to manually set up security groups, VPCs, manage all the networking and load balancing, and doing that all very manually. He said, oh, that's a load of overhead and complications you don't need. Just stick it in Heroku. That's much easier. And I think my opinion is that kind of works. And I did that when I was a developer, like a junior developer, trying to build out my own personal projects. I just kind of put them in Heroku. But I think if you're a startup, you should invest the time and the effort to learn a service that is going to scale more with you. Instead of just picking the service or the hosting platform that currently works for just your current requirements with the minimum effort. I think, there's a false efficiency. It's more efficient to get started and get from 0 to 1, but actually you very quickly are at 10. And now you're stuck with a hosting platform that works well for like a user base of 1.
Sam, it sounds like the devil is in that if at the very beginning of your sentence, of your answer. If you can set it up. If you can set it up, you can transition to this alternative. And I was really interested in that thread, because there were a lot of people who said, no, you should do EC2, no, you should do on-prem, no, you should do serverless, without any objective reasoning behind it. So it not only seems extremely subjective, but also egocentric in the sense that everybody is deciding not the best solution, but the best solution intersected with what my current capabilities are, or what my belief of what my team's capabilities are. So if we're doing, option A, and we've been doing option A forever, then even though option B is super efficient, we don't have experience with option B. So we're going to stick with option A. So it's that sort of can't teach an old dog new tricks. It's that we're going to stick with this because that's the devil we know. Yeah, definitely. So there seems to be something subjective about picking these technologies. Like how do you make that transition of defaulting to something else than what you're used to?
So I think it's always going to be something that you tend to go with what you know, especially at the start, because if you do have to spend, like if you and your team have to spend 3 weeks learning a new platform, learning a new technology, that's going to mean that you're spending 3 weeks basically not building your solution. And I think that you need to at least consider. So I think for the very first, if you're building a new startup, your absolute proof of concept, build it the quickest, dirtiest, most, the way you're most comfortable with. Once you've got a proof of concept, when you're building your minimum viable product, that's when you need to reassess and go, hey, I know this. Is it worth spending a day, a week, talking to some experts in other fields? And I think that's kind of one thing that LinkedIn probably isn't great for. It's I know this is the best solution because this is the one I know, and everyone's shouting the same thing. I think if you can get a group of people who have a more diversified experience pool, so even if I got everyone from that LinkedIn post and had them in a room and were discussing it instead of just everyone made a statement and that's kind of it. LinkedIn is better than some platforms, but having an open conversation between different people so we can compare the benefits, but pulling from people who know how to get their system working the best.
So that sounds like the startup environment will be such a natural that context, right? So you would employ 5 devs at the beginning, and then 1 dev wants to default serverless, 2 devs want to default microservices, and then 2 devs want to default to some hybrid hacked together monolith, right? I mean that does not seem an unnatural assumption to make. It might not be accurate for all industries, for all regions, for all continents, but it seems like a very easy sort of default to go to, and it's safe. It's safe to have those kinds of differing opinions within the initial team. What you mentioned about that, you're starting off and you're building a proof of concept. How familiar are you with domain-driven design?
Relatively so.
So there's this concept of secondary and tertiary and sort of supportive subdomains. And what serverless technologies, at least those that are coming sort of out of the box, like Cognito you mentioned a lot. What they do well is correct me if I'm wrong, but they seem to deliver supportive or secondary domains really well. So you need a CDN, you got a CDN. You need authentication, you got authentication. Like you don't have to reinvent the wheel, do login, register, forgot password, and email verification, and OpenID connectors to Google and LinkedIn and yada yada. So that comes out of the box. Is there something bad about how it comes out of the box? Like, why wouldn't everybody, if you steelman the counter argument, when is Cognito a bad choice?
So Cognito is designed and the way it works is really good for a lot of applications, especially SaaS applications where your revenue per user is relatively high. When I say relatively high, I could literally mean like $1 a month per user. If you've got a company with 500 users, they're paying $500 a month. That makes sense. Where it doesn't make as much sense is when you've got a very, very, very low cost very low revenue per user. So for example, if you run a forum or if you run a social media site where your main revenue comes from, say, advertising or something other than a user directly paying a monthly subscription, now it's much harder to tie for every user that signs up, this is how much I'm earning. And because with Cognito, you pay for each user that logs in a 1 month period. So if you've got 1 million users, you'll pay 1 million times by their rate. which means you could end up spending, I don't know exactly what the rate is off by hand, but it means that you could be spending £300 or $300 on just on Cognito, when, yeah, for the first 6 months, even with a million users, your ad revenue isn't that high, or your income. So
there's a delay.
There are situations where Cognito doesn't suit as well. There are other very specific ones where there are little features inside Cognito that aren't basically because you're not writing it yourself. If you need a very bespoke, very custom authorization or authentication mechanism, then maybe Cognito isn't right for you, because a lot of it is behind a bit of a service wall. It's like you can sign up, you can verify, you can do all the password reset, but if you need something very bespoke, you may have to build something yourself. And
what does bespoke mean in this context? What features would be difficult to do with Cognito?
I'm trying to think of something now. So if you were working with, I don't know, a government department that had very specific requirements around the encryption that's required on a password. So by default, I don't know exactly what Cognito uses. It may use like SHA-256. They may say every password for any user in our system has to be going through this brand new fancy equation or fancy encryption that we've invented. And if it doesn't, then we're not allowed to use it. In that kind of situation, it's a feature you can't just extend your existing Cognito with. But I think, it's always like, it's good for the majority of situations, as I think serverless is. It can be applied to the majority of situations. It's just these edge cases or these kind of topics or phenomenons where serverless or Cognito or a specific service doesn't actually work for your use case.
Wow, Sam, that's really good advice. Like, I've never heard that advice so simply, because you did something amazing there. You connected it directly to the business model. So you connected it directly to the business model of how we're capturing revenue. How does it work? How is the technology tied into the startup at like a very high level, very early on in the proof of concept? Because if I ask a traditional developer, my expectation would be that they would be hard pressed to give me an estimate on how much EC2 will cost.
Yeah.
Right. It's just how long, like, they will struggle to give me an estimate on how long they need to implement everything, but how much is it going to cost once it's running? That might be a very difficult conversation to have. But you immediately went there. You said, if there's a high revenue per user, so if there's a lot of users being captured, so like a freemium model, if there's a lot of users being captured and only a few users being monetized, that is not a good business model for Cognito, for running it.
Those are the situations where Cognito can become more costly and then it becomes you can work out exactly,
where the breakpoint is.
The breakpoint is. If it's going to take me, or if it's going to take one of my developers like 4 weeks to write our own custom authentication, it's going to cost this much. If I go with Cognito, assuming we have 100,000 users, to spend that much you can actually work out exactly how long it would take. So you're working out your return on investment for developing it yourself.
Prior to the decision to implement it.
Prior to the decision.
So that's amazing, because that is already a business analysis level of technical decision making. Because I would not expect a developer to be able to make that decision. It's like, hey guys, we're developing this new feature. Are we gonna be premium? Are we gonna, how are we gonna hook the monetary capture system in? So that seems to be very much a maturity model that's necessary to make that decision. Somebody where the developer is making the decision and he doesn't have these answers, I would say they would default to EC2, let's say, or default to some kind of other cloud solution. that doesn't cost per user, but instead costs per database. So if we fill that database with 2 million of inactive users, there's no inherent cost to that. I mean, no inherent cost per user.
Per user, yeah.
Per user, at least, not until you fill up the database and the credits become a problem, or updating the indexes becomes a problem. So the whole topology space of the decision-making process is different. So if I'm making serverless decisions, okay, let's not generalize, sorry. If you want to do serverless with Cognito, then you need to consult your business analyst first on how Cognito will be used, how many users will be monetized, because that will heavily influence whether Cognito, at least financially, is a good decision.
Yeah, that can affect it. And I think I've seen a couple of other examples where people have started a startup, and it might be something like a video editing tool where you can click some buttons on a UI and you get like a number of credits. So you might pay $1 for 10 credits. And every time you upload an image, it gets automatically processed and sent back to you. That costs 1 credit. So now for that one process, you have a revenue per process, and then you can actually tie that directly to the cost. So it's a Cognito login, plus it's an API call, a Lambda run. It might be that you use, let's say, Comprehend or one of the other AWS services. So you can actually say, this is exactly how much it costs to serve that request. And therefore, you can tie that one request to a revenue and say, actually, we've got a direct markup. Every time someone clicks that, it costs us like 1/3 of a cent. We're charging 10 cents, and therefore we're making this markup. When it gets a little bit more tricky is when you have like a monthly subscription, because you have to estimate how many API requests, how much usage a single user will do in that time period. So that's when it does become a little bit more vague and a little bit more, an average user might do this. You may have a superpower user that uses 100 times more than the average user.
Of course, because it's not,
exactly.
You have the Pareto distribution, 80-20, you have many different organic sort of non-tech influences on why a certain user would be different. You have whales with gaming, with mobile games especially, you have power users when it comes to advertising and analytics. I used to work in ad tech. Like every ad tech ad network that I worked with, there's usually one big whale and 1 million small advertisers, right? So it's always that, and you're always building the system to support both. It's very rare that you say, okay, we can afford to kick, these thousands of users off a platform, or we can afford to kick, this
one big
exactly.
client. Yeah.
So it sounds like there's a process to that, which you just said, that is very much serverless related, or at least that the decision to do it prior to technical implementation is serverless related. Is there, how do you start this process? What do you call this process? Is this part of architecture? Is this business analysis? Who does this?
So I would probably say this is like at a very high level, it's an initial business assessment crossed over with an architecture kind of role. So you're not saying we're going to use exactly this Lambda. This Lambda is going to call these exact services, but you are trying to validate and verify that you can remain profitable and both at low scale, but also as you scale up, can your business model scale with the growth of your users? There's loads of other business models out there, and I think this is kind of where
Sam, you're using a lot of behind the scene assumptions that I don't know. I might know them, but they might not be obvious to me. So we're talking about, when you said architect, we're talking solutions architect, right? So we're talking somebody who is explicitly an expert in AWS, and perhaps in like a startup focused or SM or small medium business focused part of AWS, because AWS is huge. I open up AWS's index and it's like it's how much, 273 different services, and
it keeps
and by
growing.
the time, I don't know who's watching this video right now. You from the future, I don't know if are there 1,000 right now. That's super interesting. So there seems to be a triage going on, right? So what are the most expensive startup, web technology, maybe blockchain, maybe e-commerce, maybe some kind of back office / front, premium SaaS.
Yeah.
Not, this is let's say the boundary of what we're operating in, like this niche of these types of startups, companies, small companies, tech companies, etc., consultancies, agencies. What in this context, what are the big AWS serverless money eaters? What do you need to be calculating before implementation? Not we will figure it out later, but before implementation. As a solutions architect who now talks to the business analyst person, where do we start? What is the most expensive, potentially most expensive thing?
So one thing that I think a lot of people forget is CloudFront. So if you're hosting your app in S3 and you're using CloudFront and you're having lots of users, like a lot of users requesting and visiting your website, because
what's a lot? Millions,
like 100,000 a month, okay. Let's say, and there are
unique visits.
100,000 unique users a month.
Okay,
and there are actually some tools out there, and like there is a really good Google Sheets document that's out there, and I'll try and find the link and stick it in the show notes. But
yeah,
where you can choose like an example architecture. So it's either an e-commerce app, I think like a chat app, and there's like 5 or 6, and you can say how high or low traffic you are, and it will say approximately here is the cost for running an example e-commerce application on AWS. And especially for things like social media, if you're building a social media platform, serving and retrieving lots of images can actually be quite a large CloudFront cost. And that is, for anyone that doesn't know, it's where AWS basically caches any assets, images, HTML, JavaScript local to your users so that they get faster responses, but you are paying for them to cache that. So that is one thing that I think catches a lot of people out. Yeah,
so that's an in-between cache that is like a read before cache that is geographically optimized.
Yeah.
So CloudFront, is that the most expensive one? Is that why you started with that one?
I think I start with that one because it's the ones that people never really think about. They think about how many Lambda requests am I going to get? How many API requests? DynamoDB, the ones that kind of jump to mind as, we're going to be using lots of this.
Yeah, compute and DB, right? So
yeah. So compute and DB, everyone thinks of those. They work out how much it's going to be. It works out that using your 100,000 users a month, it's going to cost you $23 a month or something like that. And you're like, oh, perfect. You build it, you deploy it, and then you get hit with a CloudFront bill that you hadn't expected. And it might be hundreds of dollars. And it's just one thing that I've seen a lot of companies that I've worked with who didn't expect that when they first launched.
They got negative surprise on the billing
side.
Yeah,
exactly. But I think it also it massively depends on what kind of architecture and what kind of patterns you're doing. If you're using a lot of event bridge and lambdas, then work out the costs for those. If you want to use step functions, they can be really efficient. They can also cost quite a lot if you're having lots and lots of transactions inside step functions.
I'm glad you mentioned that, Sam. If you can interrupt this here, because to slowly loop back into the original question of who is this for and who is this not for. So what you just mentioned, there's 2 things, right? There's that surprise bill. Yeah. So immediately somebody who is a leader or an organization that is extremely unwilling to increase their, how would you say it? They increase their level of uncertainty, right? So if they get super uncomfortable with an increase in uncertainty, You know, it's somebody who might want to do a little bit more traditional. I want to know exactly when it's done and how much it's going to cost.
Yeah.
Serverless is on the other side of the spectrum because it brings a level of uncertainty to the cost structure. You know,
Yes, it
and
does.
the most certain is on-prem, right? So most certain is on-prem as long as you have somebody maintaining it. Then somewhere in the middle is cloud EC2, and then the way other side of the spectrum is serverless. And I think that is a valid fear for a lot of people in that adopting serverless requires a level of comfortable, you know, it's the who was this? Tony Robbins mentions it already, in that the quality of life is in direct correlation with the level of uncertainty you can comfortably bear, right? So that requires a level of personal maturity, or at least somebody in the organization to carry that confidence in dealing with that uncertainty of maybe there will be a surprise bill because we were successful, right? So that has to be, or because we made a mistake. I mean, it's usually that one that people get pissed off about.
Yeah. And I think the point you made there, where like there are a lot of people who are very used to, because it has been the de facto for generations, that on-premise, okay, I'm spending $30,000 on this server. That's a one-off cost, and I know that's fixed. Whereas then you move to like the EC2, and it's okay, I have an hourly cost. I know how many
credits,
servers
or just virtual credits. It's not even hourly. It's just okay. One Friday spike is this much, right? So I know.
Yeah. So, and you can kind of accurately predict your cost, because unless you spin up an extra server, unless you have very, very unpredictable traffic, you kind of know, okay, that's how many servers we'll have. That's our monthly cost.
Of course, you're a startup. You're dealing with a lot of uncertainty, right?
But yeah, but with that comes, I know how much it hasn't got a correlation between revenue and expense. So if you get more
not
users,
immediately.
Yeah, if you have more users, that doesn't drive up your cost, but you can also drive up your cost without ever getting any more users. With serverless, it kind of switches. So it's like we have our infrastructure deployed, our AWS bill will increase. But if we've got our business model right, the reason it's going up is because we've got more users. The effect of having more users is we actually have more revenue. And as long as that is in a beneficial enough ratio, then basically the more users you get, the more eventual profit your company is making, even though your expenses are going up.
I see a lot of uncertainty coming in here, or rather a sort of, Spannungsbogen, the Germans call it, right? It's the deferring immediate gratification into the future. You know, it's this sort of, there's a potential for revenue, there's a prediction, there's a estimate, there's a certain level of uncertainty in spending, also scaling, but also uncertainty in spending and scaling. So to tie it back to the who is this for, who is this not for, like who makes these decisions, number one was absolutely the organization needs to level a certain higher, more mature level of uncertainty. And the number two is you need more discipline, or rather you need to be inspired to deal with a little bit more planning upfront. So the business analyst side needs to talk more to the solutions architect or the dev before big decisions are being made, which is very much contrary, I would say, to the more cloud EC2 side of things with microservices, where those conversations are 99% of the time, in my experience, more product oriented. So I'm not talking to the business analyst on like, okay, but realistically, how many users first month? So I know, so I know which technology to pick. Rather, it's like, okay, but where do you want the user journey and feature to go? So I know which technology to pick. So there's an immediate asymmetry there in that decision. So it's maturity and uncertainty. In my experience, this is very, how would you call it? Very soft, very subjective, very emotional. It's very empirical on how to deal with this. And we humans are very much emotional, irrational beings, very much irrational beings. What you're talking about right now is super rational. If you tell me, Dennis, why are we re-implementing the wheel again? How many times in your career do you need to re-implement the login and registration and forgot password? I'm like, well, one more time, because I'm really good at it now. It's only going to take me 2 days. Yes, but Cognito and just put it down, right? So that is an immediate irrational conversation, because I might not be ready to bear that uncertainty of, well, but that might cost a lot of money, and I don't know if it will. I can't guarantee it won't. So that irrational conversation on a bigger level seems like, okay, there's a lot of uncertainty. You take away the uncertainty. So if the business owner wants to continue making decisions within that new uncertainty, I need to hire a serverless expert to bring me the certainty back.
Yeah.
And I think that's where you come in.
Yeah.
So how does that conversation look like? How do people contact you? Because I think that this touches on the timeline when people reach out to you, right?
Yeah. So I've been working with basically startups for the last 2 years, helping them basically make the most of serverless. Interestingly, most of the startups that I end up working with have already gone, okay, we're going in with serverless. They've made that decision that the speed of development, the benefits that are available through serverless are what they want. And normally it's more of a, okay, we've got to the point where we are working and we're running, and we're just uncertain about what's going to happen over the next 2-3 years. Like, through my own experience, I've worked at a startup where we definitely went through a lot of things, ran over a hell of a lot of potholes, and have discovered loads of things where, in retrospect, it's like, of course that was going to happen. But when you're designing it and you haven't had that experience, so working with these startups, it's trying to evaluate what they've done, trying to give the engineers, the architects at those companies a little bit more experience and direction in their knowledge, but also occasionally just going, yeah, that one thing you've designed there, in 8 months, what's going to happen is that partition is going to get overfilled, and it's going to become really hard to, or some really technical thing that is going to become a roadblock in the future. And that is normally where I find companies are reaching out. It's we're going with serverless. We just need to make sure that we've not messed it up. So reducing, as you say, reducing your uncertainty for the future by getting someone who has been there, done that, to basically validate and just optimize with that extra experience. And
is there anything that you can share? Like, what are some artifacts or some conversations that you produce in corporations? Like, so the company, I talk to Sam. What do I get? Like, what is my pill that gives me the certainty back? What are some artifacts that you produce, or some conversations or guarantees, or just like a thumbs up? What does that look like?
So it very much depends, again, at what stage. So earlier startups, it's often...
What's the most common? What's the most common?
Most common is working with like a startup that is running, and it is kind of a knowing that now that your architecture has been reviewed by someone who has been specializing in serverless for 7 years. And like, I don't give a guarantee if anything goes wrong, then it's my fault, because there's always going to be unknowns in software development, not just in serverless. But yeah, just having someone who has been there and basically they've reviewed and delved deep into how your application is working. And I think from both the technical, which often is the side missing, but also, as we talked about earlier, like the connecting the technical architecture side of things to the more business analyst kind of almost like business model side of things. It's how do these things work together? and does your architecture and the solution that you're building actually solve a solution? Sometimes it is actually what you've done is good, but in a couple of years, you're going to have to move to something maybe more traditional to scale up. But that's only when you're getting to really big scales, because Lambda and serverless, it scales really well. But if you're trying to reach a really, really large market like social media, like forums, then the scale, as you scale up, it tends to be that your revenue per user does actually decrease slightly.
Yeah. There's a curve, right? Like it wobbles
Definitely,
slightly, especially in like traditional SaaS companies, especially those that are B2B. What's the most common? I don't know if there is one. Maybe there's probably a lot of differences and unique scenarios for every company and every engagement you're dealing with. What's like the most common thing you find that is over or under engineered? If there is something.
So I think at the moment there are so many different ways of approaching serverless that there aren't particularly one or two things. I think database design, especially with DynamoDB, it's getting a lot more well understood. The DynamoDB book is amazing, but I think that there are a lot of startups who are using it just in a very simplistic way and aren't making the most of what it can do. I think that's something that a lot of companies could invest in upskill their current developers to be able to make the most of Dynamo. But I think in general, serverless is quite a young, relative to, compared to like EC2, it is a very young architecture framework or set of tools, and it is changing. So I think the thing that most companies don't invest enough in is actually the training of their staff. So making sure...
What kind of training?
So anything from, like, there are online courses where, so for example, if you decide to go with GraphQL and you go with AppSync, it's an awesome service. And yeah, you can get started, you can build a relatively okay app, but if you want to really get the most of it, then Yan Shui has an amazing course on it. Just send your developers, it's not too expensive, and just upskill them. Having your developers constantly learning what not the newest trends, but learn what the new best practices are, finding out what patterns the really like bleeding edge companies were doing and have actually maintained, because there are some companies out there that are on the bleeding edge that will, if you're, for example, Netflix, or if you are Slack, you can afford to completely rewrite your whole app using Dino. And I believe that's what Slack may have done, actually rewrote their whole app in serverless and Dino. That's fine. I'm not going to tell any of my clients to do that. But what I am going to say is look at what Slack was doing. Well, look at what Slack is doing now that they started 2 years ago. So what can you learn from these big companies? And the serverless community is weirdly, like, they're very happy to share what they're doing, more so than a lot of traditional architectural.
It's more collaborative.
It's more collaborative. There are the framework like the CDK and the serverless framework, where there are a vast number of plugins, especially for the serverless framework, where a company's gone, oh, it'd be really nice if the serverless framework could have this utility. They build it, they publish it, and now you can make the most of the experience and the work that they've done. So I think, that's investing in both formal and informal training, giving your developers the chance to go and meet and talk with and learn from other companies that are using serverless. I think that's going to, in the long run, mean that you don't miss out on the benefits of serverless, but you also make sure that you're mitigating any potential risks that come with it.
On that topic, experimentation, bleeding edge.
Yeah.
How big of a threat is vendor lock-in? I know AWS probably even has an acronym, right, for the 5 or 6 services that if you use them, you will never leave AWS. I think they have an acronym for which 6 those are.
I didn't know that.
If I start using, let's say, AppSync, right? You mentioned AppSync,
Yep.
and AppSync. I'm using AppSync as a GraphQL intermediary. I'm having my own authentication server. I'm running RDS, and I'm fiddling around a little bit with Kinesis, let's say, okay,
Yep.
because I have some event system in the background. I'm taking a more experimental hybrid approach to this. How difficult is it to say, oh, this was a bad decision, I want to undo this decision? So AWS, the framework, the serverless approach, and I feel there's, and again, my experience here is limited, but I feel like the tooling for building stuff offline is worse intentionally than it could be, just to keep you on the AWS web console. To sort of keep, to be able to sort of communicate, to get you on the social network of AWS, of the console itself, of the network. So how do you know? Is this your finding? Well, what's your opinion? What's your take on the whole vendor lock-in problem?
I think there's 2 problems you touched on there. One is vendor lock-in and not being able to migrate away. The other one is like developer tooling for serverless. I think the first one, my question would always be, what scares you about vendor lock-in? I get a lot of questions or a lot of comments, especially on LinkedIn, about vendor lock-in, and I ask, are you scared that AWS is going to delete your account? Are you scared that they're going to double their prices? And I never get a firm response from 95%. Occasionally, there are some people who say, I've been screwed over by, for example, Azure expiring one of the services. I don't want to be in a situation where my platform provider stops. Mm-hmm. So, for example, you could say, oh, what happens if they got rid of Amazon SES? All of a sudden, I've got to find a different email service.
Well, what happens if they get rid of Amazon SES in Russia? The question is usually not global. It's usually, hey, can I use Kinesis in Nigeria?
Yeah.
It's usually that. It's not a vendor lock-in. It's usually political or geographical. It's like, hey, is Kinesis GDPR compliant? Well, yes, if you use it like this, but then I'm using it because it's simple. But if I have to use it like that, it's no longer simple. So I'm just gonna, use my homebrew custom code approach to it. So it's usually a little bit more complex to it. My concern, if I answer personally that question of what am I afraid of vendor lock-in, my immediate problem with vendor lock-in is similar to what we spoke about with Valentina on hexagonal architecture in yesterday, about the C#, about the sort of Microsoft opinionated approach towards architecture and domain-driven design, is that it enforces a certain direction to coupling. So when I'm vendor locked in, I do suboptimal coupling decisions with the framework I'm locked into. So rather than using the framework as a plugin to my system, and I architect my system to be about my business, I architect my system to be about AWS, and then the architecture of what that is representing, my business somehow emerges from that. Like, as an architect, that is my first problem. Like, I don't want to architect AWS serverless and then make it serve my business. I want to do it the other, and then make it make my business depend on it. I would rather do it the other way around, where my business is running with a system that's been architected to be serverless agnostic, not even serverless, but like AWS serverless framework agnostic, and then plug that in. That seems to be very difficult when the thing that you're architecting away from lives in the cloud that you're trying to architect away from. So that might be my first resistance, let's say. I know it's subjective, but from any kind of clean code, clean architecture, and just general guidelines that I received regarding architecture, this is a big no-no. About, I start using serverless. I need to use that tool to deploy. I need to use that tool to manage, my event handler, logging. I can't hide it. It's so low level that I can't hide it. Like it needs to be number one into my system. And that makes me a little bit uneasy. Maybe I'm just on old-fashioned.
So you're saying that you don't want your architecture decisions to be as directly influenced by the technology that you're going to be using instead of the business requirements that should be defining what your architecture looks like.
I think that covers 80% of my decision, but to give that a little bit more nuance, you've captured it very well. What I would add there is that I want my architecture primarily to capture the business use cases. So that, hey, the business wants to do this and the business wants to do that. And then if I say, hey, serverless seems to be a good decision at this scale, I want my architecture to represent the use case, and then the developer to figure out the implementation. And using Kinesis right now, or using Cognito right now, is a temporary business decision that serves the architecture. A lot of architects, or just developers who happen to be architecting, so inexperienced architects. So I think this ties into that training aspect. They will do it the other way around. Like they would naturally, in the spirit of saving time, they would do it the other way around. Okay, we're doing Cognito. Okay, I will couple my system to Cognito as much as possible to move faster. And that seems to be a very pragmatic approach that comes with what you would later call technical debt, when you say, okay, but this is now a problem. We can't, like, that region, it has latency, or that, that cluster is more expensive, that East Coast cluster, we have to have it there because that's the only region that supports that special version of Lambda that we want to use. And that was super expensive. And our main user went away. So now we have to undo everything. And it has that, it makes architecture decisions more rigid. At least from my perspective, I want to make sure that I want to control which decisions are hard constraints that I've introduced. It's like, I will not change my mind on this for 6 months. And then that helps us accelerate. I will not change my mind on this for 6 months. And that helps me accelerate. This thing, I'm not sure I want to be able to change my mind on this, like database schema. I want to be able to change my mind on the database schema every day, right? Because maybe we're a growing startup. So I want to be able to actually adapt to the business analysts changing his or her mind every 2 weeks. The whole serverless nature of things, and the way the frameworks and the tooling is sort of pushed, it seems to be they want to be the thing that doesn't change in 6 months. So that is my, let's say, resistance to that.
Yeah, I think that is something you need to consider. It is that the balance between we want to go fast and develop with the least amount of effort versus we want to be as flexible and as modular and as adaptable in the future as possible. I've seen serverless applications that are like, I've seen one application that was designed to be 100% like platform agnostic. So you can stick it in AWS, you can stick it in Google Cloud, you can stick it in Azure, or you can stick it in a Kubernetes instance, and they designed it to work perfectly with all of those. That's always possible, but the two drawbacks are that you first need to spend that extra time to create and basically modify and mask those connections to these services. And that does work. And you can have your, like, I've got a database interface, I've got all of these other interfaces, and it can work. And behind the scenes, you can switch out from MongoDB to DynamoDB. So yeah, the upfront cost of actually developing all of those extra modularity is one drawback. And the second drawback is now you're limited to only using the features that every service has. And someone beautifully put it as you're defaulting to the lowest common denominator.
Which is nothing, like zero. It's very bland. It's very
it's very bland.
Yeah.
You can't take advantage of Dynamo partitions. You can't take advantage of MongoDB's like search abilities. You can't take advantage of, I don't know, Google Cloud's database might have a really cool way to like modify your queries so you can query across multiple columns. You can't take advantage of any of those things. So I think it depends on what size of startup you are or what size company you are. If you are so big that the risk of staying with one platform is a genuine risk that you are willing to spend a lot of money to mitigate, that's fine. I think for 99% of SMBs or startups, you're spending money mitigating a problem that is way less likely than a new competitor coming along and wiping the floor with you.
Sam, I agree. Like this common denominator kind of thinking to architecture is an anti-pattern. You know, it's very fragile. It's not. It doesn't solve any business problems. With Valentina, we mentioned yesterday a similar, perhaps topology of problem with hexagonal architecture. You know, when people say, "Oh, you should," Uncle Bob mentions this a lot, where he says, you know, dependency inversion. The point of making your database a plugin into your system rather than the other way around, rather than having like a symbiotic relationship with it, is not that I'm going to change my MySQL database with a Postgres database, right? Because then I need to write my queries DB agnostic, but then I lose, you know, the complexity of window functions that Postgres has, or the simplicity of not having foreign keys in MySQL, or the point isn't that. The point isn't that I'm going to change my database. The point is I want to be able to change my use case without having to think about my database. You know, if the dependency is inverted, I don't have to think about my database when I'm changing the use case, when I'm changing the front end, when I'm changing the middleware, when I'm changing authentication, when I'm changing the ACL layer, when I'm changing logging, when I'm changing anything that might be either cross-cutting or like so deeply refactoring a core functionality that is coupled to that system, that I can do it in isolation and write tests for it and think about it, design it in isolation. I don't have to, you know, oh, I'm going to deploy EC2. There's a new version of this and that microservice, but I also need to orchestrate the deployment with updating the database schema and migrations. So there's a sort of coupling to that. Then there's a dependency to that. Then that other microservice also has to be deployed in sequence. So there will be downtime. So we need to put an event system in between to sort of mitigate that. Okay, now there's eventual consistency involved, but and there can be the new version and there can be the old version at the same time. So the event schema also has to be versioned. The consumer has to be able to consume both versions, and the consuming side has to have migrations. Like if that is mismanaged, that becomes a big ball of mud, a distributed sort of anti-pattern, a fragile monolith that everybody dreads. And I think the dread of going there is the same kind of fear of doing serverless and then being locked in and then having the same problem with that, in that I cannot independently change my use case because my Lambda graph is complex and I have no idea how to refactor it. So how is change expressed in, you know, if I'm expressing change with changing requirements and then TDD and refactoring, adding tests, refactoring tests, and then refactoring implementation, what is a natural way of doing something like that with serverless?
So one of the
TDD
things
compliant?
So one of the things that I really like about serverless in general is the fact that it is, especially like the Lambda code, the things that where you're writing the business logic 99% of the time, every single Lambda should have like single responsibility. So if you are changing your DB schema, you can create two separate Lambdas that perform the same task, but one's for version 1, one's for version 2. And you can try out things, you can test things, you can very specifically design your Lambda to do this one thing really well.
And how do you fan out that decision of, I want to A/B test on my Lambda pipeline?
There's loads of different ways of doing that. You could have like pre-Lambdas that then fan it out.
Like an event bridge filter, maybe, just to have them masked.
There's lots of different ways of doing it, but the ability to, like, it's not, I have to re-architect this whole microservice. It's, I have to re-architect maybe just with one Lambda. And this is also another reason that I really like it for introducing new functionality to an existing app is you can add just a single Lambda. You can add a single API endpoint to your existing, you could have like an EC2 based system and just have one new nice little functionality bit of code in a Lambda function, and that runs in parallel. And over time, you can basically switch out the existing function or the existing monolith functionality for new Lambdas. Or if you've got an existing system that you're trying to, you've architected yourself into a corner, or you've used a platform, or you've used a service that, and you've tightly coupled it, you can recreate or re-architect that and have them both running next to each other and just gently move your architecture to this new design, new pattern, this new service, whilst always having the existing one left behind. So you've got a fallback.
But how does that sounds cool if one person is architecting that? How do you manage complex cloud formations when multiple devs are touching it at the same time?
So I think that isn't that the same with how do you manage a complex microservice with multiple developers writing on the same code?
Yep. I mean, but on offline, if we're doing continuous integration with trunk-based development, I can sort of at least imagine that and have intuition for that, for how that works. What is the equivalent of that in like a serverless? Because I can't write cloud formations and then just rely on the pull request to guarantee me that the cloud formation will actually run, because so somebody might run it locally on their machine and then commit it, but it's already live in AWS.
Yeah. So I think this is probably one of the more interesting things, and this is kind of what you touched on before, that some of the developer process, the like development life cycle of software in serverless isn't as mature as it is with more traditional architecture, but there are some really cool and really powerful patterns out there. So because it's serverless, you can spin it up and it doesn't cost you anything for it to exist. So you can have a pipeline. So whenever someone creates a pull request, you can actually trigger that to run up and spin up a new deployment of that architecture into a test account. And then you can test that deployed real world infrastructure from the PR. As soon as the PR is approved, that just disappears. So you're testing real deployed.
But if that thing is talking to the production DB, that's probably not.
Yeah, so you wouldn't do that in the production account. You would do that inside its own isolated account, and you would normally have, depending on how you've structured your teams.
But then I have the same problem I have with the Git flow, sort of. Like Git flow is an anti-pattern if you're doing so having feature branches, long-lived feature branches is an anti-pattern if you want to do continuous delivery. What you're suggesting is the same topology of an anti-pattern, in that every dev perhaps should have their own test account and then have their own version of the entire network. But then that contradicts continuous delivery, because now I have to test it locally. But me testing it locally does not guarantee it working once I synchronize with all the other people who are also making changes to the system. Right? So
why does it have to be tested? So you wouldn't test it locally. That's the point. You're testing.
I mean, locally in the test version of just me.
Okay, yeah.
Okay, but maybe you didn't make that assumption. Maybe you just have a common test account where everybody's testing at the same time.
So I've seen it done in quite a few different ways. I've seen it especially when you grow to a team of.
What would you recommend? If I'm setting up that process, what would you recommend?
This would depend on how big you are. If you are a team
two teams,
of
two teams, 10 devs each.
Two teams, 10 devs is quite a big team, but
I know, but like let's say 4, 5 of them are touching serverless stuff, and then the rest are front-end rated and designers.
Okay, yeah. I would suggest each team has their own AWS account in which the commits that they do can be tagged. And yeah, 2 teams, 2 AWS accounts that are test accounts. So as my team, I know what else my team is working on, and we merge into the feature that we're working on. And whenever that gets pull requested into either our feature branch or into our team's development branch, then that can be deployed to our account and we can test that feature.
Interesting. So we're doing continuous integration post deployment.
Yes.
That's it. See, that's very unintuitive for me for not doing this naturally. And what are the benefits of that? So I can have like a really realistic AWS powered.
Well, you can have basically a fully deployed version of your app that is just connected to the code that is in pull request.
Mm-hmm.
So you can have the front end app. You can have that's constantly updating because behind the scenes, the code in your test accounts React app is in that S3 bucket. Mm-hmm. So you can make sure that the front end and back end work together. You're testing your application basically full end to end. You can have automated testing. You can have all of that built into it. So as soon as it goes up, you have a script of requests that go to your back end, and you can test. Basically, you can touch all parts of your architecture. Where I have seen other companies, and I've done this myself as well, is like local emulation.
Mm-hmm.
And local emulation does work, but when
what does local mean in this context?
That's like on your personal machine, you run like serverless local, or you run the equivalent for SAM or the CDK, where you're actually running a Lambda.
But SAM and CDK are not feature complete, correct? Like they do not allow you to like do like cross region partitioned DynamoDBs. Like you don't get that.
Yeah.
Realistic.
So this is the thing. There are features and there are technologies that just aren't compatible with local emulation.
Yeah.
And there are mocks for things like S3. There are mocks for things like Event Bridge and for step functions, but it's not going to be exactly the same. It's not going to work perfectly the same compared to when it's deployed. Mm-hmm. So that's why I prefer not to run emulation locally. I'd rather just actually get it deployed to an AWS account where all the services are real. And from there, we can run our tests.
But if I'm treating the AWS bucket, so to continue with that example, 2 teams, 5 serverless devs, solution architects, cloud architects, they're touching that, each of them having their own account on AWS. If I'm treating that test account like a continuous integration, continuous deployment, sort of like mutation testing, or maybe even continuous integration, automated testing, bed, where to do that. Can I run unit tests in that AWS account on the cloud without needing my laptop?
In theory, yes.
But it's not common practice.
No, so normally unit tests I would run. I would deploy as
Like I
part
can't,
of
I'm thinking about it like Cloud CI right now, right?
Yeah.
Where I'm deploying it and then it hosts it and then it has an environment where it runs the test that I told it to run.
Yeah.
I
So-
cannot, I can't, there isn't a one-to-one natural translation to that by using a test account in AWS.
Is there not? Would that test environment that you're running all of your tests in not be that AWS account?
Perhaps if I use Circle CI for that, but then Circle CI should have deployed it, not the developer, right? So here the clumsiness comes in of like who has CloudFormation access to that test account.
So no one should. So when you create a pull request, your automated deployment tool, Circle CI, GitHub Actions, that is what should be deploying to that test account, not the developer themselves manually making changes.
Fair.
So that makes sense. That test account is the equivalent of building your, building your Docker container that has all of your dependencies in and then running your tests. You can also have, because they are Lambda functions and they are basically just in my case, TypeScript functions.
Yeah.
You can have a full suite of unit tests that run outside or run before you actually deploy into the account. So unit test first, then deploy it into the actual AWS or into the test AWS account, run your integration tests where you're basically just hitting the API endpoints with a known request, and then you can check that some other artifact happens. So something gets written into a database, or for example, this other Lambda has been triggered. You can have all of that tested. And then obviously, if you want to go one step further, it is like using something like Selenium to drive your front end. Oh, yeah. I've not touched front end development in quite a long time.
I am talking to Nick next week, and he's a very strong sort of clean architecture TDD for React developers. Yeah, so that's very unique because I've never seen that before pushed so well.
Yeah.
So I'm really excited to talk to him next week. Next Thursday, for anybody who's watching, that's October 20th.
But yeah.
So is that your ideal pipeline?
So I think for a team of that size, that is probably the architecture I would at least start with. I think one of the advantages...
missing? You said start with, like what's missing from your
So
ideal?
it would be more that there are often unique requirements from specific teams, how they work, especially like how project management work, how your testing is organized. Do you have like physical people who are testing your application every
QA, regulatory, security?
All of these kind of things. There are adjustments you would make, but I think that would be a good template to use for a team of that size.
Fair.
Obviously, as you scale, you've then got to consider, have we got 20 different teams all with their own test accounts? What happens when those get out of sync? Then it's I need to merge this into the actual
then you get the octopus problem again, which is what continuous delivery is trying to solve with keeping
exactly small. So they become scaling, not challenges, but just growth things that you will learn as a company when you are changing in size. But I don't think that they're going to be any more difficult or any less difficult than if you are a company using Docker-based Express apps, or if you're a company doing like a massive Kubernetes cluster. So
Sam, we keep talking about serverless. Like when is a company serverless and when is it not serverless? Like I use, even for EC2 microservices, I will use Route 53, RDS, EC2, SES, SNS.
Yeah.
CloudFront, etc.
Yeah.
At what point am I serverless or not serverless? Is there like a cool kids club of like you need to use at least Kinesis or Lambdas to be serverless? Is there serverless architectures that you know of that do not use Lambdas?
Yeah. So I think trying to strive to be serverless is kind of, you're chasing the wrong goal. If you're aiming to be serverless, that's the wrong thing. What you should be doing is focusing on like that serverless has some benefits. I will use it when those benefits are useful to me. So as you said, you use SES, SNS, those kind of services because you don't want to have to write your own custom email server, manage that, and control that.
It's cheaper,
So,
right? If I have my VPS set up, like my VPC set up, I would prefer using that if I can over SendGrid. If I don't need that level of analytics right now, or volume,
yeah,
or guarantee of delivery.
but yeah. So I think I've seen applications where everything, like some companies, everything has to be serverless, and I always used to be of that opinion, like, oh, I'll do everything I can to avoid using a server. But there are use cases where actually a server is the only option. A use case where it makes more sense than using using Lambda and API gateway. And I think it should never be that serverless is the goal or that serverless is the only option. It should be that my advice would be that know how to use serverless to make the most of it, and then make an educated decision around whether that is going to be providing you the value and the benefits over a more traditional architecture. I think that there are a lot of solutions out there that kind of people went and stuck it on EC2 because that's what they knew, and they're missing out on either speed of development, they're missing out on possible features, or they're just spending loads of money hiring a DevOps team to sit there and monitor
and wait for deployment problems,
right? Scaling protocols, all of this kind of stuff. A lot of it disappears. And like one example would be, we did with a previous startup, a payment solution. If you look at the PCI requirements for Europe, there's like 68 things that you've got to tick off. Going with, if you do with AWS, AWS, just by hosting it in EC2, take about 20 of those responsibilities, like the physical security ones.
That's really reasonable. Yeah, that's really helpful.
If you move from an EC2 or Kubernetes based to a serverless based, I think you only have like you have a third of the total number of requirements are actually on you, because serverless actually takes away a lot of the operational risks that someone like payment compliance requires. I've got an article online that kind of breaks it down and says, like, here are the things that you need to worry about for PCI. Here's the things that AWS does. Here's the things that serverless does, leaving you with 12 things that you need to focus on. And then even those 12 things like you need database encryption. If you use DynamoDB, there's one button you can click and your whole database is encrypted to PCI standard. You don't need to think about hashing keys or trying to do any complex logic when you're writing and reading data. It just kind of works out of the box.
But this is obviously a very specific niche in that,
yes.
PCI compliancy, like which industries would be wanting to outsource that rather than do it on-prem with like a
Stripe.
Is it, sorry?
With the Stripe, you mean?
Yeah.
Yeah, I think most companies, but that's a very specific example of where serverless has a lot more benefits than just the auto scaling. So everyone goes, serverless, you just mean Lambda. You just don't want to have to manage your EC2. And whilst I don't want to have to manage an EC2, that isn't the only benefit. And
Mm-hmm.
there are lots of use cases where serverless can be used to give you an unfair advantage in the business world.
So for PC, okay, never mind. We're not building a fintech app right now. Or e-commerce and managing payments manually, right? Like, that's what I have Stripe for.
Yeah.
So it's the idea that you touched on managing EC2. It's not really that I'm managing EC2. I don't want to manage scaling EC2 that I'm managing, right? It's not so much the problem of I'm managing an EC2 instance. It's I have to introduce the whole load balancing and stickiness and multiple EC2 instances, and God forbid that I'm scaling that, and then I have to also manage the virtual network, the private virtual network, the routing for that, and then I have to also manage Route 53 a little bit more, and I need ELB, and then I need to set up, and and then I need to employ 2 more people to be able to scale to an equivalent of an auto-scaled Lambda instance, if I want regional scaling, right? So I think that is the better parallel to that analogy. And we touched on it in our architecture kata. So up here, usually up here in the link, I will put a link for your video on your channel for the viewers who are watching right now. We did a clone of Calendly, and you and I did it very differently. I did it like EC2 and a little bit traditional microservices. It was a bit exaggerated on both ends.
Yeah.
And you did it pure serverless. So even beyond what is reasonably, you might do it EC2, but you had 0 EC2 instances in your example, which I really liked. Most of our differences primarily came from questions of, okay, but how would you scale this, right? And then my rebuttal to that was usually, well, okay, but how would you deal with regulatory exceptions, in a specific region? The question from you to me was, okay, but how would you scale this? The question from me to you was, okay, but how would you introduce an exception in a certain region? How would you introduce an exception in Europe? How would you introduce an exception in Russia? How would you introduce an exception in South America? And that was very interesting to see the architectural differences about maybe not regulatory, but perhaps on the aspect of just customization, perhaps localization, to step away from that security, compliance, and regulatory side. Let's just call it localization. If I have Lambda and I'm auto-scaling it, and Amazon and AWS takes over all of the scaling issues, how do I introduce localization artifacts into that system? But with EC2, I sort of imagine how to do that. I sort of have, okay, this is this type of server, that's that type of server, and we scale it in separate buckets. How would you introduce that in Lambda? Would you have separate Lambdas for those types of behaviors and have a DynamoDB to sort of, how do you manage the complexity of that nature?
So I think this would very much come down to the specifics of how we're solving it, but on a general level, I can, like, off the top of my head, I can see 2 main approaches to doing this. The first is kind of more similar to what you described, which is where you would have a Europe version of your app, you would have a US version, you would have a Asia version and a Russia version. So you would have a separate app. Well, it'd probably be a very similar stack, but it would have slight modifications, whether it's to your database schema, whether it's to what data you're saving based on a Lambda function.
Mm-hmm.
And that can work, and that does work.
But they wouldn't have overlaps.
So they would have, I would probably describe it where you have a business, where you have a central repo that contains most of your business logic, and then each of the serverless deployments basically pulls it in, whether you use node modules or whatever it is, and you then apply the ones that are appropriate to your region, and you can then also like override or adjust the default ones by passing in different connectors, passing in, you could design it so you can pass in, here is the schema I want back for getting something from a database. The challenge with that becomes you're now managing 6 different AWS stacks, each very slightly different, in the same way as like you're now managing 6 different EC2 EC2 images or AMIs. Like, are they written exactly the same, or how do you, like, if you're making a core feature update, how do you make sure that's applied to all of them in the same way? But yeah,
and you have that problem of platform versus shards, and are the differences? Are the teams the same? Are they,
exactly. And even just like having 6 repos that are almost the same, like, unless you've got a whole team dedicated to each region, then there is always the possibility of a developer making the wrong change.
But that is one of the complexities. Sorry for cutting you off, because you touched on a very important topic. A lot of software architecture and software design in general comes to this problem of, well, I created a generic solution. Maybe it's a shop, maybe it's an e-commerce, and now you want an exception for this category, or you want an exception for this, or you're doing SaaS, and you want an exception for this tenant. Like, this tenant wants to white label this and have an extra feature just for them. Like, do I have, a full copy of the system? Do I have an inheritance model to all of the things they are trying to change? And that really touches the core of the complexities in a software architecture, because generally that's what we're working on. That is the primary thing we're working on. Do I make it specific or general?
Yeah.
Somebody wants to change something, but keep it the same. Maybe it's A/B testing. I want to change something for these users. Maybe it's regional, or maybe it's desktop versus mobile. Like, I want the mobile users to have this thing that we cannot have on desktop.
Yeah.
Well, okay. Well, is that just a front-end artifact, or is the backend server also aware of it? Like, so that topology of, I want an exception. I want a specific case on top of the generic platform. So that topology of these kinds of problems really touches on the hard problems. This is why software engineers exist, to deal with these problems, I think. That is the primary problem that we're solving, to navigate the problem space of, well, you need to make an exception somewhere. Exception here, exception there, and then we need to figure out, okay, is this the general case, and then that's the exception? Or is that big paying whale the main thing, and then everybody else is just, to cover for the bottom line for experimentation? Like, who are we catering to? Are we creating 2 separate systems, and then they could sort of collaborate on a microservice hub? That is, in essence, what software architecture is about. And we saw this even in our Calendly clone and in our coding kata, because we also had 2 types of users. One type of user, the host, also came in 2 types. They could be a free account or a business account. Then the business account also had like sub accounts where, like, you're either the owner of the business or not the owner of the business. And then if you go to the same Lambda functions, well, I now have to have 4 if statements in that, or a switch statement in that Lambda function, which is an anti-pattern, right? Like, this Lambda function is now fanning out. It should either just fan out or implement one of the 4. It should not be doing the same thing. And God forbid doing all 5 at the same time, fanning out and also doing the logic, because you have a high timeout on the Lambda. And if there's fan out logic that is cross-regional, you want that to be on 2 separate Lambdas to do the fan out and the at region compute, separately, I'm assuming. But that complexity of general versus specific is, I think, at the core of software architecture, at least in 2022. That's why people like microservices. We can say, oh, this is a specific exception. Okay, I'll spin up a new microservice and try to reuse as much of the existing microservices as possible, and then just capture the exception here at this one boundary.
Yeah. does that not end up in the situation where you have 40 different microservices, one for each of these little exceptions, and it becomes incredibly hard to manage?
Well, compared to what? To a monolith, where I have all those exceptions in if statements in functions that are general, right? So I mean, we need to compare it with something. Compared to what? Like the complexity is emerging from the business, not from the tech stack. The business has exceptions, you know, like the business has, well, I want to serve American customers and I want to serve European customers and I want to serve people on Android, iPhone, and the web. And there's some old website there in Brazil that for some regulatory purposes, I really enjoy having and maintaining. Those are all business complexities. And we as software developers want to manage those. But if I'm managing them in a monolith, it quickly becomes which type of animal is this? You know, like polymorphism only gets you so far. And my question to you on this topic is, what are your modalities to managing this? You know, are you doing TDD? Are you doing a mix? Are you doing something exotic with serverless? Are you doing something I might not know about? Are you a follower of clean architecture or more hexagonal, or are you more like a serverless monolith? Is there a monolith kind of equivalent to serverless architecture?
There is definitely an equivalent monolith to
Tell me about it.
where it's just, it looks exactly the same as a normal monolith for an Express server. It's just each Lambda is written in, well, each Lambda is then its own thing. And you just have every single service in your whole application all running through one repo. And that is your app. It's like serverless monolith is the thing is, it can work, and it can work relatively well, because some of the, especially when you've got a small number of developers, when you don't have that many services, you don't have some of the limitations, because each Lambda scales individually. You don't have those challenges of, oh, this one endpoint is taking up 60% of our
traffic
of our CPU. Therefore, we need
CPU.
Compute runtime. So you don't need to think about that, because that Lambda is just going to scale up more than all the others. And all the others are just going to fulfill the requests that they need to fulfill.
So what's the litmus test to find that fragile serverless monolith?
Pardon?
What's a litmus test to, to sort of, do you look at it and it's like, oh, guys, this is a problem? Like, do you find it very easy to diagnose that is misused?
So I find that the problems don't come from a technical, from like a purely technical standpoint. The problems are normally around developers overlapping, developers conflicting in their deployments. How do we test this application? How do we test this when we've got 30 developers who are all making completely different changes? How do we keep things in? That's where I find that the serverless monolith will fail more than like the actual deployed thing is breaking, unless there is some other underlying problem.
People are changing function names and then cross-wiring them, and then there's a copy of it and somebody doesn't know about it, and then there's two things writing to the same database where it shouldn't be, and then there's consistency problems, stuff like that.
That I would say is a lot more rare than just developers getting annoyed that like they're updating a function and someone else has modified it since they pulled it from master. And that's where I find the most frustration. That's when I would say, okay, now we're going to try and break this down into smaller like microservices, but still keeping
and that's
serverless.
architecture. So you're sort of adopting clean architecture here, single responsibility principles. You're sort of changing the mentality of how people think about this functions, not so much how they're using it on AWS.
Yeah, so I think a lot of the kind of microservice approach and mentality can be applied to serverless, but you've then got like the added benefits on top of that of each individual function is its own microservice in underneath that, so it has one like truly one responsibility, and that enables like that little bit of extra flexibility.
Sam, you dodged my question on whether you're doing TDD or not.
Oh, TDD.
Yeah.
I personally don't use it, but I think testing is definitely vital. I think that TDD, in my personal experience, I've never been with a company that has grown to the point where they were like, TDD has saved us in serverless worlds.
You might find the previous episode interesting.
Okay,
we can put a link of that as well in the doodly-doo, in the apply-do.
And that's with serverless or just TDD in general?
No, that's traditional TDD. So yeah. For you, like, I was wondering if you're doing TDD with serverless, because I don't know what that looks like. And I'm wondering, my general understanding is that very few people who do serverless do TDD. And I'm wondering whether that's a problem with the stack or whether that's a problem with the mentality of how, maybe, is it just the latency? Because the point of TDD is that you have very low latency and having like a high trust signal for the machine telling you, hey, yes, this will work.
I think this is the challenge kind of with testing serverless, because
latency, but
it's not necessarily latency, it's the fact that you can't run everything locally. So you can't run Event Bridge locally. You can't run SNS, SES, all these other things.
So you'll be testing such a small unit that it'll be completely unnatural to test, because you'll have to mock like unreasonable details into Event Bridge.
So I definitely use not 100% TDD, but for certain things I will write tests first for if there's a specific business logic that is particularly complex. It's taking that approach, but it's because
you want to have some safety of, okay, this is a big chunk, it's complex, I can't hold everything in my head, I want to test. But you said test first. Test first and TDD are very different. I don't want to go into details about that right now.
That's a whole nother conversation.
To wrap up, because we're coming short on, what is it, 90 minutes, 2 hours?
Yep.
How are you on time?
I can stay on for a little bit more.
Okay. How much is that? Wrap up in 20 minutes. Is that cool with you?
Yeah, that would work for me.
All right. There's one aspect of serverless that we haven't touched upon, and that is the database.
Yes.
What is like a reasonable topology for serverless databases? Like each, if I'm doing microservice with Lambdas, with serverless. So let's say there is a separate repo for every, if I'm using the domain-driven design terminology here, let's say I have a bounded context for a particular set of functions and a different, you had this in your drawing when we did the architecture kata. It was really good. I like that. It's like you have a group of Lambdas here. That's one response. That's a group of responses. That's a cluster of responsibilities. That's billing. You have a group of Lambdas here. That's account management. You have a group of Lambdas here, and then you have Cognito, right? And we don't need Lambdas for that. Cognito is its own sort of context, and it's secondary to our business application.
Yeah.
When you were doing that, there was a sort of natural overlap of, okay, so this thing has its own Dynamo, and this thing had its own Dynamo, and I had three things which each of them had their own RDS. What is a reasonable topology for serverless? Is there like one for each context? Or is it just one giant RDS, one giant Aurora, one giant Dynamo? What's your experience? Because some of them sound like fragility concerns and anti-patterns. What is the worst you've seen, and what is the sort of middle of the road approach?
So with serverless, the main database that we tend to use is DynamoDB, because that can be a 100% truly serverless database. And the patterns for that kind of depend on what you're used to and what you're comfortable using. But the two main ones are like a single table per article or per
Entity.
Yeah, exactly. And that is very common. That works really well.
It looks like machine code to me. I'm sorry. Like you showed me. I was very diligent in trying to keep up, but it still looks like machine code to me.
Yeah. And that's going to be single table design, where you have the other one is single table, where you have a single table that has every single entity in. And then because DynamoDB has some very specific ways in which it can be queried, you kind of, when you're designing the schema for not your database, because your database schema will just be every record has an ID, it has a partition key and a sort key, and then either a second partition key and a second sort key. That's fixed.
And then it's document.
It's what does the rest of the entity look like?
And it's really about querying, like how many different ways are you going to query this chunk of data?
Yeah, exactly. And it's a little bit more involved than I can just, then if you go with an SQL database, you can kind of just put everything into the database. You kind of have to have a fixed schema at the start.
But it's not scalable, right? I mean, it's not, but there is Planet Scale now, which is interesting. It's sort of these partition distributed SQL servers, which AWS for some reason is not doing. Like Aurora is not exactly that. Like it's trying to be, but Bigtable was trying to be, but then problems. What is the problem there is that with Dynamo, single table design, the thing that is unnatural to do is joining data across entities.
Yeah.
How involved can I get on the complexity of schema management? Should I have like a DDD, like an aggregate root, and then have like a super document? Should the DynamoDBs be the things that I'm projecting to? So should I treat the DynamoDBs as the centers of truth from a read replica standpoint, or as the write master standpoint, or do I just think about it the wrong way?
I think, especially when I really got to understand single table design, I'd been using Dynamo at that time for like 3 years, and I just had to completely rethink the way I approached database design and database schemas.
Completely rethink.
So yeah, it was just the idea of, if I'm trying to get, so for example, if you've got a database and you've got like a user addresses, you've got user details, and then you've got, I don't know, some
orders and orders
and invoices. You've got all this other stuff.
Yeah.
The fact that I can, with one single query, just say, get me everything with partition key equals user ID, and I get all of those different types of entities in one query, that kind of changed the way that I had to think about how I was designing my tables. If you were doing that
correct me if I'm wrong, you haven't actually solved that problem on the DB side. You're solving that problem with AppSync.
Nope.
So no?
That's on the database side, I can do, I can query where partition key equals user ID. And because both the user address, the user orders, all of these start with a partition key of user ID, I can get everything.
Even though they're different entities.
Even though they're different entities, I can get all of those entities with a single query, which means I'm doing one request to the database to get multiple different kinds of data. This can bring up...
And the documents will be over different... I mean, it's a NoSQL database, so it's not reasonable to talk about a schema. Like, we don't have a schema. We have indexes, right? Like, we have partition keys.
So that,
perhaps I'm thinking about it the wrong way.
Each of the records might have a different set of fields. So the address, so each address will have like what like home address is it, what postcode, what city, and what state. That will have those. An order won't have a postcode on it. It'll have a completely different set of values on that object. And I think that's a better way. you're getting back an array of objects that are data about the user. And this means that you can really group things based on wider collections, instead of having to group things based on like, here is like this one user, just the user's address. It is actually now, I can just group all of the user's information in total together.
And those, as long as they're on the same partition key, those operations are atomic. So the eventual consistency problem, at least on that side, the DB side, is minimized.
Yeah, so each partition, the way that Dynamo does it behind the scenes is each individual. So if you had 5 different user IDs, then each user ID would be always on a single instance.
Yeah.
But there could be that like Sam Williams' user ID is on like an instance over there, and your metadata, all of your information is on a separate database. And that's why you have to query with a fixed partition key, because it goes, for that partition, I need to look on that server and then run this query. It does mean that if I was trying to say, get all orders for September, I need to have designed a different querying schema or a different partition key or index, because your orders are on one server and mine are on another. Indexes basically group data by different things. So now I can go, actually get me all orders for this month, and all of September's orders are on one server, all of November's on a different server. So it's very, very different to SQL, and it's once it clicks, you can really optimize the read requests and the queries you're doing to your database, so that you're able to basically get grouped information really effectively. And then that's still not thinking about the fact that, oh, I've never had to think about the capacity of this server ever,
or scaling it, or latency in a region.
All of that is handled by AWS. Like on Black Friday, it was something like DynamoDB did 1.6 trillion requests or something ridiculous, and that'll be a single Dynamo table, just partitioned very, very effectively. But yeah, it can scale to numbers that 99% of companies will never dream of.
What about versioning, version control, the database itself, making changes to it, deploying the changes? Is there a certain rollout period where the keys are inconsistent, where if you're changing them? Is it how messy can it get from version controlling across the dev team?
So version controlling it tends to be that with serverless, you go for a roll forwards mechanism. So instead of going, we're releasing version 2, we're releasing version 3, and we can roll back to version 2, it tends to be that we go for a roll forwards. So a lot of companies go, that's too risky for us. We always need to have something stuck in Artifactory or stuck in some other system where we can roll back, or we can A/B and have 2 completely separate instances and load balance them. You can do that with serverless. You can deploy an updated version and have them running in parallel and do load balancing. But that isn't the most common practice. The most common practice that I've seen, especially with SMBs, is the roll forwards mechanism, where databases get updated when you do the deployment. And
and you make sure the consuming code is forward and backward compatible.
Just make sure that it's forward compatible. Yeah,
forward. Interesting. It sounds like you have courses on this.
Yes. So if one thing that I really struggled with when I first started learning serverless was there were a couple of AWS tutorials out there that were kind of naff. and lots of articles.
It's a soft way of putting it.
Yeah, software. Lots of articles of people doing things, but they always went like, oh, we're going to do this one really specific thing. And then another article will do something else really specific. And then you try and put the two together and it's structured differently, or it's not. They've done things in different ways that mean that it's just really hard to make things work. So I created a YouTube channel, and now I've created a course where I basically help people go from absolutely never used serverless in my life, maybe even never used AWS, to like building their first ever API, building their first Dynamo table, all the way up to building like a chat system where you've got live chat between two people and or a group of people with message history, and event driven architecture where it relies on the record changes in database that triggers an event, which then triggers another Lambda to process it, and that fan in and fan out. So I've got a course that will teach you how to do all of that.
Link below.
Link below.
Watching.
All the all the code is there, and you can follow along. And
you have a new course. You have a new course as well. Is that the new course?
That is the new course. Yeah,
it covers everything.
It covers everything, and my aim with that was, how can I get how could I, if I was taking this course and I wanted to get a job as a serverless developer as quickly as possible, what do I need to learn to be a useful member of a team?
Wow, that's amazing.
I've tried to basically make sure you focus on that and cut out all of the extra nonsense around the side.
So there's Dynamo, serverless, deployment artifacts. What did I miss?
So we talk about like WebSockets, API gateway,
okay.
Cognito, and security, as well as like general like how to structure your application and how to
architecture.
Tooling. And it's all done in TypeScript, which
amazing.
If you're using JavaScript, I would massively recommend upgrading to TypeScript, because
for anybody who's using Java, I would recommend as well upgrading to TypeScript.
That's an interesting transition. Java
I just
TypeScript.
Sorry for ruining your sales pitch, but I've been doing a lot of code katas now with Java, and I just hate how verbose it is. I want to define a little object, carry over a few, a plain object with some properties, and I have to write 14 lines of code just to be able to have like a simple artifact, and it really gets to me. I get annoyed. I get annoyed writing that much boilerplate for just basic stuff. In TypeScript, I can just type it, and if it can infer the type, I don't have to type it, and it's amazing. And I don't think we think of it as this sort of silly tacked on type safety thing onto JavaScript, but it's a really mature language, especially because of the type inference. I don't have to type the type it will be before I put the keyword. I put the keyword in, and the editor already knows what type it is, because if it can infer it, it will. That is a much more natural way of writing code. Anyway, TypeScript. TypeScript rant. Okay, there's that. What about working with you? Let's say somebody has already done your course, or a company, a startup has hired people who have these skills. There's a fire, there's a problem, or maybe they just want certainty, maybe they just want a guarantee from somebody who's a little bit more experienced that they're on the right track. What problems, who in the company should call you? What role, and with what problem?
So I think the perfect person to reach out would be the CTO or the lead dev, someone who understands the software from the higher level. So like mating, as we talked about earlier, mating up the business requirements with the technological implementation. And so if you're interested in that, then it's anything from reviewing your architecture and making sure that there's no big potholes in your future, to helping train up your staff so that they can basically make better architectural decisions and build better software in the future. So feel free to reach out if you're needing some help with anything serverless.
Awesome. Sam, is there anything else you would like to share? before we wrap up?
No, I think that's it. It's been a very good call, but
Yeah, it was pretty
yeah.
cool. This one. So to our viewers, thank you for, I know this is a long one, but Sam and I have been really kicking it off with the architecture katas and sort of the bridging the gap between the serverless and the sort of more server-ish microservice world for startups and SMBs. Thank you for staying with us. If you found any aha moments, please leave a like, share your aha moment in the comments, perhaps. If you're interested, you can subscribe to follow the future episodes. The next episode will be with Nick regarding TDD and architecture in frontend, in React specifically. That's going to be super interesting. Something of a unicorn combination that I'm really excited about, because the craftsmanship in general on the sort of front-end side of things has been lacking, and it's going to be an amazing episode. For anybody who's watching the recording and is not live right now, thank you. I hope AWS is still alive and around, so this video is relevant. And yeah, thank you. Till next time.